Okay, so here's the lesson plan for today. We're going to start talking about group analysis, and this is part one of a two-part lecture. And today, what I want to focus on is really two main things. First, when you aggregate subjects at the group level, what is the right model of variance that you should use in doing such aggregation? And in particular, what is the difference between them, and how do they affect your ability to draw inferences towards the rest of the population? So that there we will be covering fixed effects, random effects, and mixed effects analysis. Then the second half of this will be about how do you actually implement a group analysis. And what I mean by that is the full way of doing it is what is known as an all-in-one analysis. But this turns out to be very complicated, inefficient, and computationally very hard if you do it on fMRI data, where each data set is often an aggregation of several tens or hundreds of thousands of voxels, each of which with a time series associated to it of several hundred time points. So while that is what we wish we could do, it's just not efficient in the domain of neuroimaging. So what we do is something called a summary statistic approach, which in very short means you do a first level analysis, and then instead of carrying forward the actual data, you just carry forward the summary statistic. In our case, that might be a beta or a z statistic, something of that sort. And then that is what you aggregate at the group level. But in order to do that in the correct way, so in order to do that in the way that makes it identical to the all-in-one we wish we could do, but it's just too difficult to implement, you need to have sort of certain, you need to implement the analysis in sort of a certain way. And that is what I want to cover today. So let's go.